crude oil is an extremely complex mixture that contains petrol, kerosene, lubricating oil, and solid asphalting residues. Modern-day technologies are increasingly using petroleum as a fuel and energy, either in industry, transportation, or as a daily household needs, which ultimately leads to many environmental problems. A promising method that has been studied as an additive to minerals, especially nitrogen and phosphorus, which is chemical fertilizer application, has been studied to have the advantage of biodegradation in land. However, the use of chemical fertilizers is a concern because of the interactions between soil amendments and natural soil constituents may be possible. Based on a research article we found, researchers studied and searched for cheaper and environmentally friendly options of enhancing petroleum hydrocarbon degradation. Secondly, to evaluate and compare the biodegradation performance of the application of inorganic chemical fertilizer and animal manure such as poultry manure, pig manure, and goat manure in the bioremediation of soil contaminated with petroleum hydrocarbon mixtures.
Materials and methods. Firstly, the samples were collected at specific location. Then the manure was dried, crushed, and stored at room temperature. Meanwhile, soil samples were homogenized, dried, sieved, and stored in a polythene bag at room temperature in the laboratory. Step 2. The soil and animal manure characterization. The soil and the different animal manure were characterized for physical, chemical, and microbial parameters such as pH, total organic carbon, total nitrogen, available phosphorus, potassium, total heterophobic bacteria, and total hydrocarbon degrading bacteria. Step 3. The isolation, characterization, and identification of soil and animal manure microorganisms. The soil and animal manure sample was separately subjected to dilution and plated on neutron agar and incubated at room temperature for 24 hours. States that yield 30 to 300 colonies of bacterial isolates were accepted. After incubation, isolated bacterial species were subjected to morphological, cultural, and biochemical tests. Experimental design and soil treatment. There were 5 sets, each containing 3 earthen pots for each treatment and control. In each pot, the soil was contaminated and mixed well with the petroleum hydrocarbon mixtures. The contaminated soil in the earthen pots was amended with each of manure respectively. The contaminated soil in the earthen pot T4 was amended with NPK fertilizer. The control earthen pot with the contaminated soil were not amended with either the animal manure or NPK fertilizer. The pots were incubated at room temperature in the laboratory for 4 weeks. Samples were taken every week and examined for further analysis. Estimation of residual total petroleum hydrocarbon (TPH). The residual TPH was determined in accordance with American Society for Tests and Materials. Fourier transform infrared spectrophotometer was used for the test, and TPH concentration in the sample were determined by using the stored calibration graph in the software. Lastly, the kinetics of degradation. The rate of petroleum hydrocarbon biodegradation was measured by the application of first-order kinetic model equation to the biodegradation data.
Now, we will move on to the results from the article. These are the figures that can be found within this article. And let's focus on this one, the degradation profile of petroleum hydrocarbon. Based on figure 1, the degradation of petroleum hydrocarbon has shown that poultry, piggery, and goat manure treatments showed greater petroleum hydrocarbon reductions than NPK fertilizer treatment. Next, we will focus on these two figures, the growth profile of total heterotrophic bacterial population and the total hydrocarbon degrading bacterial counts. Based on these two figures, the total hydrocarbon degrading bacteria and the total heterotrophic bacteria increased to the maximum with increase in the remediation period up until the 3rd week, which would decrease on the 4th week for all the fertilizers. Moving on, these are the tables that are given within the article. the microbiological and physicochemical properties of soil and animal manure, and also the specific degradation rate constant values for soil treatments. The microbiological and physicochemical properties of soil, poultry manure, piggery manure, and goat manure is clearly shown. The specific degradation rate constant K values determines the effectiveness of the animal manures and NPK fertilizer in the treatment of soil contaminated with petroleum hydrocarbons. So, the higher K value indicates a higher effectiveness and vice versa.
The experiment carried out by Agarry and his team involves spiking soil with petroleum hydrocarbon mixtures rather than the use of age-contaminated soil. The reason behind this is to elevate the bioavailability of hydrocarbon mixtures to the intrinsic microorganism. The treatment strategies that are used in this particular experiments are animal manures, which are poultry manure, piggery manure, and goat manure, and also chemical fertilizer such as NPK fertilizer. This figure shows the total petroleum hydrocarbon reduction as a function of remediation period. Based on the graph shown here, the degradation of petroleum hydrocarbon by all of the 4 treatment strategies began in the first week of remediation period and slowly continued up to the 4th week. This means that the application of animal manures and chemical fertilizers can increase at the same time, enhancing the petroleum hydrocarbon degradation. However, we can also deduce from these results where the uses of animal manures have a higher hydrocarbon reduction rate compared to the NPK fertilizers. This may be because of the higher nutrient levels and hydrocarbon utilizing bacterial species in animal manures compared to chemical fertilizers. So, this indicates that the animal manures act as both nutrients and microbe carriers. If comparing between the 3 animal manures, poultry manures have the highest petroleum hydrocarbon reduction rate.
Biodegradation rate of soil hydrocarbon petroleum mixture are improved by the application of poultry manure, piggy manure, goat manure, and NPK chemical fertilizer in soil media. The soil treated with poultry manure show the greatest degradation and the least degradation of soil treated with NPK chemical fertilizer. The use of poultry, pigs and goat manure can be one of the most searched ways to remediate natural habitat with crude oil. One of the benefits of animal manure are to minimize their carbon pollutants due to their diverse metabolic ability. Next is relatively low cost, which is suitable for decontamination of petroleum polluted soil. Lastly, the benefit is the environment benefit from the application will increase soil carbon and reduce soil erosion. The limitations are technology is relatively new and its operation is not well known. The patent rights of the technology to end users as they are claimed by some individuals. Lastly, the procedure is very complicated and messy, lead to inconsistent product results. For future recommendation, first method use need more monitoring and adjustment of the required condition. Next, the volatile contaminant needs to be contained before escape into atmosphere when hazardous toxic is used.